This video is going to be a quick video just going over some of the key points from section 3.2 to 3.3 as we're getting ready for our summative quiz coming up over those sections. So what we're going to quickly recap is the points where a derivative does not exist. So we know we have four conditions where a derivative will not exist. One of those issues will be where we have corner points, and we know with corners we're watching out for absolute value functions. So if we consider y equals the absolute value of x, we know its graph takes on this V shape, and because of that corner at x equals 0, we know that our function y is not differentiable at x equals 0 because of that corner point there. Another way of saying the same thing is that the derivative does not exist at x equals 0. The next thing we have to watch out for is cusps, and we know these can occur where we have rational exponents. So for example, y equals x to the 2/3. And if we were to graph that, we would get something that looks like this. And so at x equals 0, we have this cusp. So again, we know that that function is not differentiable at x equals 0, which is the same as saying the derivative does not exist there. And again, that's because those left-hand and right-hand derivatives are not equal. The other place where we will not be differentiable is anywhere we have any type of discontinuity. So in general, we're watching out for piecewise functions, because we know we could have some kind of jump discontinuity there, or rational functions. And there we're specifically looking out for vertical asymptotes. And then finally, our last issue with differentiability is anywhere that a vertical tangent would exist. And again, here we're watching out for rational exponents. So in this case, we could look at y equals x to the 1/3, right, which is the same as the cube root of x. And that graph, we know, takes on this shape here at x equals 0. So again, another case where that would not be differentiable at x equals 0. So those are four cases where we know that derivative is not going to exist. So the only other part we're going to go over quickly are some of our derivative rules that we've learned so far. So our first shortcut is the derivative of a constant. So if our function f of x equals c, and c is a constant, we know that f prime of x is equal to 0. So for example, if f of x is equal to 4, we know that f prime of x is equal to 0. And again, that's just because if we think of this graphically, f of x equals 4 is just a horizontal line, and we know the slope of that horizontal line is equal to 0. Next, for our power rule, we're looking at functions like f of x equals x to the n. This rule you guys have already shown you're really good at. We know that f prime of x equals n times x to the n minus 1. And our last two rules that we've learned thus far are the product and quotient rules. So product rule says if I want to find the derivative of the product of f of x times g of x, so I want the derivative of that product, I take f of x times the derivative of g of x plus g of x times the derivative of f of x. And the last rule we have is our quotient rule. So now if I want to find the derivative of the quotient of f of x and g of x, again, this is where I've used the phrase low d high minus high d low over low squared. So our low is just our function in the denominator. So low d high means take the derivative of the function in our numerator, minus high, so I take the function in my numerator, d low, so the derivative of the function in my denominator, all over low squared. So high d low low d high minus high d low, all over low squared. So again, that's just a quick review. Tomorrow you'll be doing a review over these first 3 sections to get you ready for the summative quiz.